Hello, I'm Jing Liu and from Cadence. I'm working on the DDR controller support. Today we're going to talk about one feature of controller. It's called ECC, error checking and correction. So when data is stored in the memory, sometimes it can have errors due to the temperature variation, voltage variation, etc., or some radioactive decays. And for certain systems and applications, it is very critical that the data has to be very accurate. There's no errors in the memory. So ECC is one way to add more layer of protections. We can have ECC in a controller. When write the data into the memory, the controller will calculate using the ECC algorithm to calculate adding one check bit for each byte. Let's see, 8 bit of data will be 1 bit ECC code. So 64-bit data will be 1 byte. ECC code. So the ECC will assure the data stored in the memory is correct, or it can if there's errors, they can correct the errors, or at least can detect the errors. With our ECC algorithm, we can correct 1-bit error in the data and also detect 2-bit error in the data. When we store the data in the memory, the controller will calculate the ECC code, so there has to be a space to store the ECC code in the memory. There are some two schemes to store the ECC code. One is called out-of-band ECC. So that is using separate memory part to store the ECC code. When we do the write data to the memory, at the same time we will write the ECC code to the separate address space for the ECC code. So when we read the data from the memory, we will read the data at the same time we will read the ECC code as well. So the write and read is going to be one write and one read, but the memory bandwidth will be increased. So the original 64-bit data bandwidth will be increased to 72. There is another scheme we call the inline ECC. It will use the same memory space at the memory device. It will use 1/8 of the memory device space dedicated for the ECC code, and the other for the data. So in this scheme, when we write the data to the memory, there are going to be a separate date to write the ECC code to the ECC space. When we read the data from the memory, there's going to be a second read from the ECC space. So it will consume some memory bandwidth. Which scheme is better for a system? It depends on the system's requirement, and it's the kind of consideration what you need and which is best for your system. That's all for today. I'm Jing Liu, and thank you for watching Whiteboard Wednesday.